Hydrocarbons are the simplest organic compounds that contain only hydrogen and carbon. They are obtained from petroleum. There are three types of hydrocarbons: alkanes, alkenes, and alkynes. Alkanes, which are also known as paraffins, have only single covalent bonds. Therefore, they are saturated. Some of their uses are energy sources, solvents, asphalt, white gasoline, lubricating oils, and materials for the petrochemical industry. Combustion or oxidation. An alkane plus oxygen yields carbon dioxide plus water plus heat. This reaction has to be always balanced. Alkenes, also known as olefins, contain double bonds, therefore they are unsaturated. Some of their uses are energy sources, polymers and plastics such as ethylene or propylene, and hormones for vegetables such as ethylene. Alkynes, also known as acetylenes, contain triple bonds, therefore they are unsaturated. Some of their uses are energy sources that produce high-temperature flames for welding and cutting. Also, polymers and plastics such as ethine and propyne.
In combustion, a hydrocarbon, which can be either an alkene or an alkyne, plus oxygen, yields carbon dioxide, water, and heat. This reaction always needs to be balanced.
Hydrogenation. A hydrocarbon, either an alkene or an alkyne, plus hydrogen yields an alkane or an alkene. In this reaction, the hydrogen breaks up the double or the triple bond. Halogenation. A hydrocarbon, either an alkene or an alkyne, plus a halogen yields an alkane or an alkene. In this reaction, the halogen breaks up the double or the triple bond, transforming into halogen branches.
Alcohol is an hydrocarbon with an hydroxyl group that can be classified as primary, secondary, or tertiary. For the UPAC nomenclature, you select the longest continuous chain containing the OH. You name and number branches using the known order. You name the main chain and change the ending from E to ol suffix. And for the common name, you write the alkyl group and after that the word alcohol. They are extreme polar. They have great boiling points due to the hydroxyl groups. They are liquid at room temperature, and the oxidation of alcohols can turn into aldehydes, carboxylic acid, or ketones. One of the main uses is for antifreeze, antiseptic, food preserver, beer, whiskey, vodka, tequila, fuels, etc. Ethers are compounds with a central oxygen attached to two radicals. They have very low fusion and boiling point. Most of them are liquid, they have a pleasant scent. And for the UPAC nomenclature, the shortest chain becomes the first part of the name, and the "-ane" suffix is changed to "oxy". The other chain keeps its name. For the common name, the two R groups are named separately, followed by ether. One of the main uses of ethers are solvents of sulfur and fats, explosive manufacturing, anesthetics, and antispasmodics.
Aldehydes are the product of the oxidation of a secondary alcohol. The hydrogen atom is attached to the carbonyl group and their functional group is CHO. Some of its physical properties are if it has up to 4 atoms, it's soluble in water and the solubility decreases if the number of carbon increases. It has an immediate boiling point between ethers and alcohol. Some of its chemical properties are that aldehydes are transformed into alcohols, they react with halogens, and after oxidation, they're converted into carboxylic acids. Some of its uses are aldehydes are use of methanol or formol to preserve human bodies or animals, and they're also materials for the production of resin, and they have the smell and flavor of vanilla and cinnamon.
Ketone. In ketones, the carbonyl carbon is always double bonded to an oxygen, with a single bond to two alkali groups. The simple ketone is known as acetone. Their main uses are pharmaceuticals, polymer in industries, solvents, and perfumery.
The physical properties of carboxylic acid is that from 1 to 3 carbons it's very soluble in water, from 4 to 7 it's less soluble, and more than 8 carbons it's insoluble in water. It's less dense than water and it has an unpleasant smell. Some of its uses is it can be made into vinegar, it's used in aspirin production, soap production, and the textile industry.
Esters, their functional group is a change attached to a COO continuously by a change. They have water solubility. If the carbon increases, the solubility decreases. Same at the boiling point. If the carbon increases, the boiling point increases. Some of the characteristics are that they have a pleasant smell, are high volatile.
Amines have several physical properties. Its solubility is that the ones with short radicals are soluble in water. Its toxicity depends on if amines with aryl radicals are toxic, and its aroma, it smells like ammonia.
An amide functional group consists of carbonyl group bonded to a nitrogen. Two hydrogens atoms are bonded to a nitrogen. Some of the characteristics that they are solid, have very high melting points, and if carbon increases, solubility decreases. They have a lot of uses. The most common ones are nylon, penicillin, LSD, Septrin, and Bactrin. The last two are for treating the stomach aches.